Let's get started. You ready? Happy Tuesday. I know you had yesterday off, which is kind of nice. Get to relax. That's a 3-day weekend, so no work yesterday, so that's pretty cool. I had some work, but I'm glad you didn't. Hey, take a look at my shirt. This is the 2017 5th grade shirt. Next year, you get to put your little signature on a shirt like this, and we all get shirts. I'm looking forward to it. 16, let's get started. I am doing this a little bit out of order. I'm doing 14-8 before I'm doing 14-7, because they don't seem right the other way, so we're doing them my way. Today we're looking at triangles, 14-8. But able to do that, we're going to back up a little bit first. Take a look at this. We've already studied this. You've seen angles, how two rays can form an angle between them. We've talked about that distance between them. It's measured in degrees and turns and all kinds of good stuff. Well, we know every time we see that little box there, that little squared corner, we know it's a right angle. We also know that any angle that's less than that right angle is so cute. It's an acute angle. Let's get rid of that line. We also know any line that's greater than 90 degrees, greater than that right angle, that's an obtuse angle. No problem. That's all review. That's stuff we've done. Well, in order for us to make these all triangles, we're going to basically just do this. Take my arrow leads off because I'm not going to make these lines anymore. They're going to be segments, even though that's an ugly segment. It's still a segment. Take the arrows off, arrows off. Now look at all these triangles I have. And the best part is, not much changes. If you knew your angles, you'll know your triangles, because this is now a right triangle. This is an acute triangle. This is an obtuse triangle. So all you really did in this lesson so far is connect those rays and add the tri to each one of them. Now we have triangles. And think about that for just a minute, just a second. Triangle. Tri like a tricycle means 3. Anytime you see T-R-I, it means 3. And if I say triangle like a triangle, it means it has 3 angles, one at the top and one on each corner. And each one of those angles is here in each one of our drawings. So we have a right angle, which can be a right triangle, an acute angle, which can be an acute triangle, and an obtuse angle, which can be an obtuse triangle. Now notice this. For it to be a right triangle, it has to have that square. You have to know it's 90 degrees. 90 degrees tells you right angle. How about that right triangle angle? This one has 3. 1, 2, 3. 3 angles, all of them less than 90 degrees. This is what we know normal triangles as. Let's take a, I know my triangle drawing isn't great. A normal triangle looks like that. And notice each one of the angles. See how small the angle is here, here, and here? All those small angles are less than 90 degrees. So an acute triangle has 3 angles less than 90 degrees. Obtuse triangle. There's only one angle I'm worried about. If it has one angle that's nice and wide like that, bigger than that 90 degrees, it's an obtuse angle makes it an obtuse triangle. So if we stay in that idea of right, acute, and obtuse angles, we'll be able to identify triangles just as easily. Okay, let's get rid of this stuff. We're coming up on something that I enjoy doing. Sorry, yes, there are math things I like to do. Strange. You know, as a kid, I hated math. When I was a 4th or 5th grader, hated math. I think that's why I teach math so well, because I get that it can be hard, and I get where you can be frustrated, but I figured it out. You can figure it out too. Okay, let me see. There's a bunch of things in here you can go through. There's a vocab word in here I want you to notice also. Anytime you see, let's take 2 line segments. Line segment, line segment. And I'm going to connect just the line segments. That's all. I'm not making rays, I'm just connecting line segments. Wherever line segments touch, or even actually where even rays touch, those are called vertices. That's a vertex, the corner of a shape. Oh, look, my blue is dying. The corner of a shape where those points meet. See those little line segments? Each one of those line segments meets each other at these corners. Those corners, each one of those corners is called a vertex. V-E-R-T-E-X. A vertex. You're going to see that in some of the instructions. Now, when you have many of them, you don't have vertexes. Doesn't make sense. You have what's called vertices, and this is what it looks like. Vertices. My pen would work for me. Vertex means you have one of them. This is a vertex. These are all vertices. Each one of them is a vertex, but when I put them all together, they're called vertices. So make sure you know that vocab word. That will pop up for you from time to time. Okay, let's get to the fun stuff that I like to do. And I'm kind of skipping this part in here. That's just, oh, actually, I do want to show you one part, the perpendicular lines. Let's talk about that. Because it asks you, which shapes have perpendicular lines? Well, let's give it like a right angle right here. Acute triangle, 3 angles, less than 90 degrees. Obtuse triangle, 1 angle, greater than 90 degrees. Right triangle, 1 angle is a perfect right angle. Okay, so now I want to figure out which one of these shapes has perpendicular lines. Now remember, go back to your vocabulary. Lines that run like this are parallel. Parallel. Lines that run like this and form those perfect little squares right here. Perpendicular. That went wrong with my pen there. Perpendicular. So we got to figure out which ones are perpendicular. Now keep this in mind. Each one of those perpendicular angles is a right angle. See all those corners? Inside, 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 inside. They're all right angles. So really you can get away with seeing a perpendicular line, look, like that. Doesn't that look kind of familiar to something else on the board? Yeah, right down here. Notice these lines. Let's do it a different color so we can make it pretty. Watch these lines. This one here of the triangle and this one here are running perpendicular to each other. Let's keep this in mind. What if I just kept drawing? There's that perfect cross we're looking for. Remember that perpendicular has that cross to it. There's that perfect line. We're not talking about intersecting lines. Remember those intersecting lines, the ones that just cross. They don't care, they cross anywhere. Perpendicular has to make that perfect little cross. So that's what we're looking for. Which one of these would have some sort of cross to it? Well, this line and this line, well, they intersect, but they don't cross. This line and this line intersect, don't cross. This one, intersect, don't cross. See all these lines, if we drew them long, they do intersect, they cross each other, but only one of them crosses at that perfect angle. And the giveaway, always the giveaway, perpendicular lines have that little square. They tell you there's a right corner there. Because if a perpendicular line is drawn, 2 perpendicular lines that cross perfectly, there's going to be this 90-degree angle right there. Also, just like I drew it there, there's also going to be one right here, there's also going to be one right here, there's also going to be one right here. It forms perfect right angles all over the place. So, which one of these shapes is perpendicular? Your right triangle is going to be perpendicular. Don't forget that. You're going to see that flag up on you today. All right, moving on. Moving on, let's get to the next part. I'm going to write in green there because the blue's looking icky. Okay, I want to get to this second page, triangles, more specifically. Know this about a triangle. Every triangle has 3 angles. That's why it's called a triangle. Remember this. If you take those 3 angles and add them all together, you're going to get 180 degrees. That means if I'm going to take this angle, this angle, this angle, if I knew exactly how much each one measured, and I could tell you very easily, they're all going to equal 180 when I add them together. To give you an idea, a perfect triangle usually has angles that are 60 degrees each. So it looks like this. This angle is 60 degrees. This angle is 60 degrees. This angle is 60 degrees. Now if I take those three 60s and I add them up, I'm going to get my 180. All angles, all three angles, always add up to 180. Don't forget that. It's an important thing you need to remember. All three angles of a triangle add up to 180. 180 degrees. Don't forget that. I'm going to leave that on the board for you because what you're going to see, let me show you. You're going to see things look like this. Let me see. I'm going to tell you that this part is 75 degrees. And this is on your drawing on the second page. I'm working on this one right here. We're going through the examples that are on page, here comes page 912. Make sure you're on 912 because I'm going to go through problems 1, 2, and 3. So we'll get them all up there. Okay, 912 looks like this. Okay, we have to figure out what's n. I want to know the total degrees for this whole angle, but I got to figure out what n is. How do I figure out n? I know this part of the angle, 75 degrees. But what is this? What degrees is that? You have to start thinking about what you know about angles and triangles, those kinds of things now. And if you look at this specific problem, it's giving you a hint. It's giving you a very big hint. Do you see the hint? Do you see it? Do you see it? It's right here. It's telling us this is a 90-degree angle. The whole thing is a 90-degree angle. That tells me something. It means if I took 70, let's just the other way. If I took n and I added it to 75, I would get 90, because I know the whole thing is 90. From here to here, all the way across, it's 90 degrees. Well, if they're telling me part of that is 75 degrees, all I have to do is figure out the difference between 90 and 75. And this goes back to that key strategy, and I think I wrote it in here. I hope I did. I hope I did. Maybe I did. Okay. It goes back to that one key strategy you already know. What's the opposite of addition? Subtraction. What's the opposite of subtraction? Addition. We're going to work backward on this. I'm trying to figure out what n is, and this is an addition sentence. Let's work backwards with that backward feature. This is 90 minus 75 would equal n. So if I found the difference between these two, I'm going to know what n is. Let's try it. 90 minus 75. Borrow from my neighbor. Regroup to 10. 10 minus 5. 8 minus 1. N equals 15 degrees. 15 degrees. Because we know the whole thing is 90. I know part of it is 75. All you're trying to do is figure out the last part. I know I've given you $75 and I need you to get up to $90. You just have to figure out how many you need to get there. Same idea with your angles. Let's work on another one. Leave that key idea on the board because it's very important that we know that. And that was a tricky problem I gave you there because really they don't give you a lot of information. You have to recognize that little right triangle, so it's the giveaway. All right, here's another one. Let me see, I got a short one over here. That's 35 degrees, and this is K. No, put the little degree up there. This is K degrees. I don't know what it is, but it does give us this hint. The combined angle measure is 130 degrees. It says that in the directions. It says the combined angle measure. Now, if you think about that, listen to what they're saying to you. The combined, they're putting things together. When you put things together, you're adding. So what they're saying is, if I took this number and I took this number, it's not really a number, it's a variable right now, but go with me. If I took this number and this number and I combine them, I add them together, I'm gonna get this. Well, opposite functions. If you're telling me combining this will get that, I need to work backward to get this. So the opposite of addition is subtraction. Let's take that. We could do it this way. We could do this. K plus 35 equals 130. Because that's really what it says. If you combine the angles, if you combine them, ooh, that got ugly. If you combine them, add them together, you're going to get 130. Let's work backward. 130 minus 35 equals K. I know that's going to work backward well, so let's figure it out. 130 degrees. That's my overall total. I'm going to subtract the one part I know, because what's going to be left over is what goes here. Let's do it. 0 minus 5 cannot work. 10 minus 5. 2 minus 3 can't work. 12 minus 3. K is 95 degrees. And you can check your work on this, because if we put this into the problem, let's go back and put it where they said. Because if you combine these things, they equal 130, all right? Well, we know K. We're going to say K is 90 degrees now. Let's put K in there. I'm going to say K is 90 degrees. Let's see if it works. 35. I'm going to add my 35. 0 plus 5. 9 plus 3. Oh. You see my mistake? May catch it? Yeah, I make mistakes too. That's okay. Rewrite the problem, Mr. Ratcliffe. I told you that I got 95 here, I got 95 here, so K equals 95, right? Then how come when I went back into my problem, instead of putting 95, I wrote 90? See? Mistakes. Mistakes. I knew about halfway through adding that I made a mistake. So I had to figure that out. There. K is 95. Let's try it. Let's go back. Add. 5 plus 5 is 10. Regroup. 9 plus 1 is 10. 10 plus 3 is 130. We can check our work, make sure we're correct if we use the right numbers. So in this one, K equals 95. All you're really doing over and over is making sure that whatever total they give you, you're going to find the other angle that's missing. Last one on there. Find the combined angle measure. This one's fun. And it says 35. Well, mine doesn't look very good. It's not accurate. I got it on the wrong side. This way. Okay. This degrees, 35. This degrees, 25. And it says, find the combined angle measure. Find the combined angle measure. Well, I have all the numbers. I know this angle, this small thin angle is 25. This angle is 35. An angle of 25 right here. Angle of 35 right there. Find the combined measure of the angles. Oh, I get it. Combine. They want to put the angles together to give them an answer. Now see, the other problems, they gave us the combined measure. We had to work backward and do subtraction. And now they're saying, oh, I'm not going to give you the combined. I'm giving you both of the angles. Your job is to tell me what they are combined. All that is addition. Combine them together. 5 plus 5. Tough one. 3 plus 1 is 4. 4 plus 2. The combined angle here, those angles combined, those two angles put together, is 60 degrees. Let's throw one really odd wild card at you. See what you can do. We're done with your notes, by the way. That's pretty much everything. I've gone through everything, but I want to throw a 5th grade problem at you. See what you can tell me here. Let me see. How should I do this? Let's do this as Okay. I'm going to tell you this. These two angles, they're equal. The same measure. They're equal. So, what's the measure of each angle? You have to tell me how much each of the three angles. How am I going to figure that out? I don't have any numbers. This is 5th grade. And the reason I set up 5th grade is because I want you to pay attention to this 4th grade stuff. Yes, you're not a 5th grader yet, I get that. But I want your eye on 5th grade so you know why we're doing these 4th grade things. This is the problem in 5th grade. Give us all the angles. You didn't give me any numbers. Yeah, but you have basic things in mind that you already know. First thing you already know is if I add all three angles together, it's 180 degrees. Second thing you already know is this tells me I've already got 90 degrees. I already have this. One of the angles is 90 degrees. I know that because of that square. So 2 basic pieces of information you're picking up in 4th grade, you're going to be using in 5th grade. This is where it gets a little fun. Watch this. I know if I add this one, and this one, I add them together, I'm going to get 180, excuse me. I'm going to get 180. But I know this one, so let's do this. I'm going to take away the one I know because I want to find out what's left. Whatever's left goes here. It gets split up to those because they said those angles are equal. Let's try it out. 0 minus 0, nothing. 8 minus 9, can't do it. 18 minus 9, oh, that's 90. Okay, so if this angle is 90 degrees, this one has to be broken up to here and to here. I have to break that one up into both of those corners. Now I told you they're equal corners. Those 2 angles are equal. They're the same measurement. Which means if I take this and I split it in half and I separate them, there now I have 2 numbers and they're equal. They're the same number. So what's 90 cut in half? 90 cut in half is 45 and 45. So the idea is we gave you a right triangle. You went on some basic knowledge you already knew. And we asked you, what's the total angles here? And you could figure it out without any numbers involved. They're all your numbers you bring to the table. Let's double check the work. Because if I add my new 3 angles together, it should equal 180. Let's try it. Oh, let's see. 5 plus 5. 4 plus 5. I'm sorry, 5. I do that all the time. I give away the answer. 4 plus 1, 5. 5 plus 4, 9. 9 plus 9, 18. There's my 180 degrees. That's a 5th grade problem you're going to see, but I want you to start thinking about it because I want you to see why we do these 4th grade things. Okay, we're set. Nice job. Good work. You already had your math warm-up today, so that's in good shape. Thank you. Nice job, guys. Take care. Can't wait to do this shirt with you next year. Take care, guys.